what is the meaning of the code converter. Code converter is just one decoder and encoder. You're using decoder and encoder, you are able to use that 7-segment and have your binary or BCD as a decimal on your 7-segment. So what we want to actually talk about that, our title is code converter. So what it means, the code converter actually is one decoder. So if I put one decoder, okay, here. So you tell me the input of the decoder is what? The input definitely is a code, right? You have some codes. If that's 2x4, you have the code of 2, right? So what is the output of this decoder? You tell me, you should know that. What is the output of the decoder? If you have n, you have 2 power n output here. What is the output in decoder is midterms, right? So definitely is midterms. Or you could say message, you call them message, right? And you could, anytime you could just have one message, right? Because whenever you have the codes, the corresponding midterm is 1, the rest is 0. So that's what that is message. So if you consider each of these midterm as a message. So what we want to do, we want to actually have some codes here. For our purpose, I want to have here the BCD codes or the binary. Whenever I say BCD codes, you know, that's actually is a 4 codes, right? So for example, 0 here is 40, the 1 is 001. So that means this is what I want to do in coding converter. I want to actually put the BCD codes from one side, and at the end, I want to have any other codes that I want. For this case, I want to have 7 segments. So what it means I want to actually have one unit, which I call that code converter. I want to have here 0, 0, 0, 0, and here I want to see the 0 in 7 segment. So what is the 0 for 7 segment is actually 1, 1, 1, 1, 0, 1, right? So that means these code converter should be give me 1, 0, 1, 2, 1, 2, 3, which is 7, right? So that's what I want to see how I could make that code converter. Because if I could do that, so that means whenever I have 0, 0, definitely I could have these LEDs on the 7 segment, which is 0, right? So that means whenever I have 0, 0, 0, 1, if this is a code converter and able to convert BCD to 7 segment, definitely if I connect that codes to the 7 segment, I could actually see 1, right? So 0, 0, 1 is, what is the 7 segment of the 1? So you have 3, 0. Yeah, you have 3, 0, then you have 2, 1 again, you have 0. Same thing for the last one, which is the 9, right? What is the 9 in BCD? So this is 9 in BCD. So the output of these code converter should be actually the 9. For if you check what is the codes for 9, just first one is 0, the rest is 1. So 1, 2, 3, 4, 5, 6. 6 actually is enough, right? We have 7. Yep. So that should be actually, it should be the output, right? So that means if I could do that with the code converter, so it is exactly the good thing. For example, if in the examples that we had in the lab, for example, you have one adder, add 2 4-bit numbers and give another 4-bit number, which is usually we have these LEDs as a BCD, then we need to convert this to the decimal and see, okay, that's actually add or subtraction is right or wrong. So it is nice to connect that actually BCD codes to the code converter, give the 7-segment codes and connect that to the 7-segment and exactly see that number on your 7-segment. Okay, this is the goal. So here we want to know how we could actually make that code converter. So for our case, we want to actually have the BCD codes here, and the other side of the code converter should be convert the BCD codes to the 7-segment. That's what its name is, code converter, right? Here we want to convert BCD to 7-segment. How you could do that? So this is actually how you could do that. First, you use one decoder. So definitely for our case, you tell me this decoder should be how many inputs we should have if we want to do BCD for 7-segment. So let's finish this, then I mention to that. So that means this code converter usually is one decoder. You have the codes in the input, then here you have the midterms. But then you need actually to connect the output to one encoder, right? So you need an encoder. Is it right? Yes, because the input of the encoders all the time is the midterms, right? Here you have the midterms, then encoder able to give you actually the corresponding codes that you want to go. We will go to the detail for BCD to 7-segment, but this is a general actually map about any code converter. Usually the code converter just include two parts. One is the decoder, which is connected to the encoder. But depend on your needs, that means which code you want to convert, you need to actually figure out how you could actually arrange these two, which we will talk about that today. So for now, we want to actually convert BC2 to 7-segment. We know we need to use the code converter, which is use the decoder and encoder. Let's see how we could do that, okay? So that means I want to use decoder, encoder. I want to make one code converter, which is able to convert BCD codes to the 7-segment. So let's see how we could do that. So yeah, so that means if I add the title for what I'm going to talk, I could say BCD. I want to make BCD to 7 segments actually converter, right? Or you could say code converter. Yeah, code converter. Okay. So let's see how we could do that. So definitely the first things whenever you want to actually design any the logic circuit, the first step is you exactly understand yourself what you want to do, what you want to actually design. So this is what I want to do. So that's clear from the name. I want to have one unit, which is its input is the BCD and the output should give me a 7-segment. That's what I call that BCD to 7-segment converter or code converter, okay? So I actually make one table which is somehow summarize what I want to do. So I actually comes to make one table. So in one side, what should be the input for this unit is the BCD codes, right? Remember chapter 1, the BCD codes is the 4 bits actually codes, which is somehow is the binary of that digits, right? For example, if you have 0 in the BCD, you could represent with that with the 40, right? So 40 or 000. Okay, I'm not going to just write one of them, but you know what I mean by BCD, right? So my input is actually 0, could be 1, could be 2, could be 3, could be 4, could be 5, could be 6, could be 7, 8, and 9. Okay. So whenever I say 0, because this should be the BCD. What's the BCD in? What is the 0 in BCD? Is just 4, 0, right? You already know that. So what is the BCD for 1? So it means 1, 0, 0, 0. Okay. And you already know, I'm not going to actually write all of them, but you know, whenever I say 9 BCD, you should know 9 BCD is this 1, 0, 0. Okay. So this is actually right for all of them, right? Let's just extend this. So this is actually what we have here. So just I want to first understand what exactly I want to do. I have the input, which is the BCD codes. Definitely you tell me how many inputs I should have for these BCD to 7 segment code converter. If you want to just figure out about inputs, first inputs, how many inputs? So that means input should be actually how many bits? Just think about this. You have 0 to 9, the days are 10, but you don't need 10 actually inputs, because you could actually have with these 4 bits, you could actually have 0 to represent 0 to 9, right? So how many inputs do you need? It's somehow clear. Yeah, definitely you need 4, right? So 4, and definitely they are is in the BCD. That means if you want to have 9, you should give 0, 0, 1. You could do all of them for all these digits between 0 and 9. So here I just want to just remind one thing. So I actually add one column, which is somehow is the midterm number. So if you have 0, 0, 0, what is the corresponding midterm for 4, 0? You call this midterm 0, right? You call this midterm 1, and you do the same thing for last one. Definitely you call that M9, right? So this is your input. So, and how about the output? You tell me how many pins you should have for this BCD to 7 segment code converter. How many bits we have as an output? Just type it on the chat box. How many output we should have? The unit is BCD to 7 segments. So the input is, yeah, definitely 7. The output should be 7 segments, right? So that means definitely you just need 7 outputs. So I write just actually here the outputs, which is the 7 segment, right? So that means you just put here A, B, C, D, E, F, G. Okay. So just back to this table that we already talked about that. So whenever you have BCD 0, what should be the output? Should be these codes that you have. Whenever that's 1, what is the, if this is converter, whenever you have 1, it should be, output should be 7 segments for 1. What is the 1 in 7 segment in these code? What I'm going to write in here is exactly, I repeat the same table that we already had. So okay, so help me on the 0. So for a 0, it should be definitely just F should be 0. The rest should be 1, 1, 1, 1. We already talked about that, okay? So how about the 1? For the 1, you have 1, 2, 3, 0. Then you have 2, 1. Then you have 0, 0, okay? How about 2? For 2, you actually should have, let's do this. I want to somehow mix. Okay, so just put these two. Same thing for 3, 4, 5, 6, 7, 8, 9, probably. Okay. I hope I could make these columns because writing with this pen is really tough. Okay, almost. So yeah, back here, so definitely this is 2 for, so that I just write these midterm M2, M3, this is M4, this is M5, this is M6, this is M7, this is M8 and 9. Okay, back to 2. What is the, actually, what is the 2, 4, 7 segment whenever you have, even you could actually complete this table. For 2, you have 0, 0, 1, 0, right? So what is the 2, 4, 7 segment? Again, we already explained it. 1, 0, 2, 1, 0, 1, 1. What is for 3? So you have 0, 0. The rest is 1. What is the 4 in 7 segment? Is 0, 1, 0. You have 3, 1, and this is 0. What is the 5? Is 0, 1, 1, 0, and 3, 1. What is the 6? Is 1, 2, 3, 0, 1, 2, 3. So for this is 6, and for 7 you have 0, 0, you have 3, 1, and you have 2, 0. So for the 8, definitely you have all of them on. And for 9, you just turn off the A and the O should be 1. Okay? So this is actually somehow we summarize what we want to design. Okay? So what's happened here? So, okay. So now let's see how we could design this circuit that able to get the BCD codes and actually give the 7 segment. So if you take a look to this table, what you have here, you need actually one unit, which is first, you need actually one unit to take these 4 bits and the output should be the midterm, right? See, I write the midterm. Do you remember any actually circuit units IC that able to get the codes and the output will be the midterms? Do you know what's that? So definitely the answer is decoder, right? So if I actually put the one decoder here, so let's see, yeah, it probably use some other colors here. Which color use? Maybe this one. So yeah, I'm going to put first one decoder. So you tell me based on number of the inputs, which is 4, this decoder should be, what should be its actually size? It should be how many inputs, how many outputs based on our needs. What is our input here is BCD, right? You have 4. So let I use one 4 by 16. So what you have in 416, you have 4 inputs. So these are the 4 inputs, right? So which you call them whatever you got as a BCD. Okay, I call that X0, X1, X2, and X3. Okay. So how many outputs I have here? Number of the outputs. What is the number of the output? Yeah, definitely 16. And what is the 16 is midterm 0 to 15, right? That because this is the decoder. So probably I need to extend these decoder. So let to actually make that something like this. Okay. So as you already know, you should have midterm 0, which is, I actually extend that inputs because I need them. So this is midterm 1, this is midterm 2, this is midterm 3, this is actually midterm 9, sorry, 1, 2, 0, 1, 2, 3, 4, we are on 4. This is 5, this is 6, this is 7, this is 8, this is 9. That should be enough. And you could have all of them, which is definitely the last one should be M15, right? M15 is the last one. What I actually did here, this is maybe the other color here is more clear. So see, this one definitely is M0, this is M1, this is M2, M3, M4, M5, M6, M9. Yeah, 0, 1, 2, 3, 4, 5, 6. Sorry, should be 7. This should be 8. This should be 9. Okay. So no, this is not what we want. I actually put this 0 here. So 4 inputs, and I have the all midterm, which is somehow make these midterms that I need, okay? So then take a look to this part of your table, okay? In the one side, you have the midterm. In the other side, you have the corresponding codes. So this is actually somehow this table should be similar for you. Where did you see this? If you back to our encoders topic, you actually saw that in the encoder. Whenever you want to design an encoder, one column is the midterm, so the other part is your codes. How you could make that? You actually just put the OR gates, just check the columns, right? Whenever that's actually you have the 1, so that means you just put the connection there. So that means somehow I need one encoder that's able to actually encode that midterm, but this time not to the binary, this time to these codes that you see. So that means whenever midterm 0 is 1, what I need to see, I need to have these bit pattern in the output, right? So that means you should put 1 OR for each of these 8 outputs and then check their columns. Wherever that's actually is 1, you just make a connection. So somehow you are making that encoder, but that encoder convert the midterm to corresponding 7 segment, not corresponding binary, which we did for the normal encoder, okay? So based on what we learned in the encoder design, so I'm going to this. I'm actually put one OR gate here. So this is the first one, and definitely I call this A. So do the same thing for all of them, right? So this should be for B. Definitely, believe me, this is really tough to work with this pen. So the next OR is C. So the next OR is D. The next OR is E. So the next OR is F, and the next OR is actually, these are OR, right? So this is actually G. So what's the connection? Just come here. I want to put the connection of the first OR. So C, just check the column. So wherever this is actually 1, you actually make a connection. So C, M0 is 1. So M0 is 1 for A. I put the connection here. So what else we have? You have on M2. Okay, this is M2. Where else we have M6, right? So you put M6 the connection, and where else? So you have on 8, so C8 you put the connection. Similar for the B. Okay, back to just check the column of the B, just check where in which midterm it is 1, just make a connection there. So here it is M0 is for B is 1, so for B M0 again is 1, right? So what else you have? You have on 4, 5, 6, right? 4, 5, 6. So where is 4? This is 4, this is 5, this is 6. So 4, 5, 6, and the rest, which is 8 and 9, right? 8 and 9. So put on 8 and 9. Okay. So do the same thing for the all others. So just I'm doing that very fast. So if you check that for the C, you have actually M0 again. For C, there is a M0, there is M2, M2, there is M3, there is M5. Just I put here the notes, you just check the table and see. I actually just check I'm doing right. So if I actually did wrong, just let me know. So we have 5, we have on 6. What else we have? 6, 7, 8, 9, right? 7, 8, 9 for C. Go to the D. So for D, where is the 1? The D for D is M0 again, M0. What's the else for D is 1. What is the else is 2. What else is 3? 3, where is the next is 4. This is 4. Then you have 7, 8, 9, right? 7, 7, 8, 9. Okay. Check to the E. You have again for E. You have 0. You have 1. So you have 3. You have 3. You have 4. You have 5. If I did a mistake, just type on the chat box, okay? 5. I have 6. 6, actually 6, 7, 8, 9. So 6, 7, 8, 9, and the F. For F should be start with 2, 2, 6. So for the F 2 to 6, this is 2, 3, 4, 5, 6. So 2 to this 6, then we have 8 and 9. So you have 8 and 9. And finally for G, you have M0 again. So you have for 2. So this is 2. You have for 3. So this is 3. You have for 5. You have 5. Where is 5? 5 is here. So then you have 6. So this is 6. And you have, why we don't have anything here, definitely should be 1. So then you have 8 and 9, right? 8 and 9, okay? So this actually give you the BCD to the seventh segment. Let's just check one of them, okay? Let's just check one of them. So see, I'm giving here 0, 0, 0, 0, okay? You tell me, let I use the other color here. So you tell me, whenever I give here 4, 0, which of these output is 1 and which one is 0? Tell me. Type on the chat box, so I actually write with blue. So whenever you have 4, 0, which of these output is 1, which is 0? Come on, that's just decoder, right? You give 4, 0, yeah, M0, definitely. So see, this is 1, this is 1, and the rest should be 0, right? So I put actually with the other colors, which is definitely is clear what's going on here. And the 0 and the last one should be 0. So if this is 1 and the all is 0, depend on this connection that you see, you tell me in the output, which is A, B, C, D, E, F, G, which of these outputs will be on, will be 1, and which one will be 0. So you actually comes here, you say, okay, just M0, if it's connect to any of these gates, this is OR gate. In OR gate is one of the pins is 1, the output definitely is 1. So that means whenever, yeah, you connect it to the gate, definitely the output is 1. So that means here you have connection, this is 1, this is 1, this is 1, this is 1, here you have connection. For F, you don't have any connection, should it be 1. And for G is actually 1. So F connected to the others, which is the others definitely is 0. So definitely all of them would be 0. Okay. So that means whenever you have 4, 0, you have actually these 1, 1, 0. So that means just F is not actually on. So if you connect these outputs to the 7 segment, this is what happened. So you will see just F is off, which is the middle one, and you see the 0, right? This is actually what we want to do, right? So we want to actually, whenever have the BCD 0, we want to see that 0. We don't want to convert these binary to, I don't know, to decimal and no, okay, 4, 0 is 0. We just want to see that's on the 7 segment, which here we could see that, right? So let's just have one more example, then just finish that, okay? So I just select one other color. So which is, here I use the blue, to use yellow. So I just check, you could check all of them, definitely all of them should be work. So let's just have with next example, if I give, I don't know, give me suggestion, which one we don't need to do. Let's do 8, right? So if I have 8, this should be 1, 0, 0, 0, right? This is an 8. So if I have 1, 0, 0 here, this is a decoder, right? Which of these output, which is the midterm, should be on, and which one should be 0? So tell me, whenever I have 1, 0, 0, which of these midterms should be 1? Come on. Yeah, 8, definitely. So you have 8, which is here, and the rest should be 0, 0, 0, 0, 0, and 0. Also, this is 0. So back to here. So that means whatever you have here, the OR connection, if this is 1, and see wherever is connected to the OR, in the OR gate, if one input is 1, no matter what the other is, the output is 1. So see, this is actually connected to the all gates. So that means the all will be 1, 1, 1, 1, 1. So that means you will see this. That means these LEDs will be on, which is actually 8, right? So this is actually shows how you could use the 7 segment. Definitely you use the code converter, which somehow you actually, the code converter is one decoder and one encoder. Somehow, if you back to what I mentioned here, maybe this time it makes sense why code converter is include the decoder and encoder. So this is how we did that, right? We use the decoder to make the actually the midterms, then we actually use the encoder, somehow modify encoder based on this table that we have. and it's able to convert the BCD to 7 segments. So for the next lab, probably I actually put one lab assignment which you do at least simulate that. So that means able to have the circuit that able to give here with the switch, probably you actually give a binary or BCD and it's able to show you that number, right? So if you want to do some extra work if you back to the whole labs that you did, especially for adder and subtractor, right now you could actually add a 7 segment in, even if you could have 7 segment in your inputs, which is whenever you give 4 bits input, it shows what that input is, right? And also use the 7 segment in output. So that means whenever you say, if that is subtractor, you give 8, you see the 8 on the 7 segment, you give 5, so then 8 minus 5 should be 3. So in the past, you see that 3 on the BCD codes or binary, but here you could actually put another segment in the output, which is give you that 3. So that means everything could be actually more easy to see what's going on your circuit with using the 7 segment.